Water. It's life's most basic need, but there's a water crisis in our world, seriously. More than 785 million people in our world are still thirsty. But how do we solve this? That's where we come in. My name is Zach, and my team and I are from Dallas, Texas. We've created an application known as DrinkABLE, which uses Echo AR technology as well as water quality calculation to detect whether a particular body of water is polluted or not. The DrinkABLE solution utilizes a probe that is yet to be released. This probe would utilize various sensors and microscope cameras to identify the water quality values for the various indicators, including nitrate, dissolved oxygen, saturation, fecal coliform, pH, and the number of nitrates in parts per million. Ordinary citizens or health officials in an area can attain these values through step-by-step processes found in our augmented reality easy tutorial, which we'll show you in a bit. After the values are acquired, our program will run a multi-dimensional analysis on the indicator numbers to output a score. This score will represent the quality of the water itself. I would now like to direct your attention to our CAD 3D model, which models the prototype for the probe that will be released in the future with the device. This device will be able to measure the various indicators that our program requires to produce a result. The probe is first placed in the water, and as you can see, the microscope will take a series of photos in the water. This is shown, as you can see, with a cone jutting out from the front. The images will automatically run on an artificial intelligence model, which can output a percentage of fecal coliform found in the water. It does this by classifying particles as bacteria or debris. Underneath our logo, we can see a group of 4 cylinders. This is a contraption that combines dissolved oxygen, saturation, biological oxygen demand, all of the probes that are required that are commonly found. Jutting out from each of these are flat strips. These strips house the pH strips and the nitrate strips that can easily be measured in parts per million and pH value once the strips are submerged. Together, this information will be displayed on the box found here, and it'll also have an on and off function on that box. Now let's check out the demonstration of the accompanying application that works behind the scenes with Arya.
Hey everyone, my name is Arya and I will be walking you through our Echo AR virtual manual. So how it works is our product will have a bunch of QR codes along it, like this, that show you the different modules you can access to learn about your probe. Once you click on them, they ask for access. Just give it access. Once it recognizes the image, you can hear the module. In this module, so right there, the module will continue playing, and of course, we're not going to use a pressure versus volume chart. That's just for the sake of demonstration. We plan on using our logo as the marker image, and along with that, we will have an actual video. It's just I'm so close to my screen, it's not rendering. Thank you. Now that we have taken a look at how exactly Echo AR can be used to have a digital manual, we're going to take a look at the code running behind the scenes for your drinkable sensor. So here we have the code pulled up, and in this case, if you look at the output, you can see that it's asking me for input on the dissolved oxygen, the pH level, things like that. But don't worry, the sensor, once a prototype is made, will be the one that's directly sending data to this program. And then this will simply be calculating the water quality index off of that and then outputting the overall water quality index. So currently, this code only takes in 5 of the 10 parameters for determining the quality of water. We have dissolved oxygen, fecal coliform concentration, pH, BOD, which is biological oxygen demand, and the number of nitrates. But as we continue to develop this program, we'll start including other things like temperature change. So all of these factors together, thanks to this code, can be turned into can result in the quality of your water. It will just output the quality of your water. So I'll run it right here. Suppose the amount of oxygen dissolved is 90%. So this is really good because that means majority of your water has oxygen in it. So it resulted in a 93. The scale is 0 to 100. Anything above 50 is passing. Now let's say there's a lot of bacteria, 500 colonies. We got a 44. pH of the water, 8. That's why it's an 85. That's pretty good. BOD 25, and number of nitrates, let's say 2. So overall, the quality of the water is 60 based on these factors, and this is exactly what the sensor will do. It'll just take in data, send it to this program, and the program will respond with the overall water quality or individual water qualities for each factor, and then just output it to the user.
Check out our website for more information. It uses WebGL to enable the website to be converted into different languages for different places around the world.
Now, DrinkABLE is our first step at solving the global water crisis. But if you look into it, this crisis is more of a humanitarian issue than anything. It starts with water, but water affects everything. Education, health, poverty, and especially women and children. Without basic access to water, women and children travel up to 3 miles for water that in itself is very polluted. This time spent getting water is time away from their books, away from their classrooms, away from other jobs that can earn them an income. Not to mention the enormous health implications of drinking unsanitary water. By allowing citizens themselves to analyze the quality of their water, our combination of hardware and software at DrinkABLE will allow residents to find the best quality of water for their families to drink. Thank you.